Every precision ceramic bearing begins with flawless raw materials. Engineers carefully inspect ultra-pure silting advanced AI systems to ensure unmatched quality before production even starts. Precision starts at the microscopic level. Advanced imaging and AI-powered analysis confirm every ceramic ingredient meets the strict standards required for high-performance bearing production. Precision starts at the microscopic level. Advanced imaging and AI-powered analysis confirm every ceramic ingredient meets the strict standards required for high-performance bearing production. Artificial intelligence monitors every gram of material, ensuring each ingredient is blended with microscopic accuracy. Before the ceramic forming process begins, uniform particle distribution is critical. High-energy vacuum mixing eliminates inconsistencies, producing a flawless ceramic blend for the next manufacturing stage. Uniform particle distribution is critical. High-energy vacuum mixing eliminates inconsistencies, producing a flawless ceramic blend for the next manufacturing stage. Inside the spray dryer, liquid ceramic slurry transforms within seconds. Powerful streams of heated air, designed for consistent pressing. Precision nozzles convert ceramic slurry into an ultra-fine mist. Every tiny dries evenly, producing uniform granules. Advanced automation continuously controls airflow, temperature, and particle size. The result is highly consistent ceramic granules ready for the next stage of precision manufacturing. Cold isostatic pressing applies uniform hydraulic pressure from every direction. This critical step prepares the material for superior strength and precision. Unlike traditional methods, cold isostatic pressing delivers equal pressure in every direction. The result is a highly uniform ceramic structure with improved density, durability.
Automation ensures every cold isostatic pressing cycle is precisely controlled. Timing and advanced robotics produce ceramic parts ready for the next stage of high-performance manufacturing.
Every green ceramic ball begins with absolute precision. Automated rotary forming systems shape each sphere to near-perfect dimension before the next manufacturing stage.
Speed meets precision as advanced forming machines create perfectly uniform green ceramic balls at an impressive production rate. Every sphere is automatically monitored for flawless quality from the very beginning.
Artificial intelligence and precision robotics work together to produce perfectly balanced green ceramic balls. This advanced form superior ceramic bearing performance. Every fraction of a millimeter matters. Diamond grinding wheels carefully shape each green ceramic ball. This prepares it for the next stage of manufacturing.
Advanced robotics guide every ceramic ball through multiple grinding stages, ensuring exceptional roundness, uniform dimensions, and unmatched consistency before final finishing.
Using AI-guided precision, every green ceramic ball is ground to exact specifications. This critical process guarantees your balance, accuracy, and performance in the finished ceramic bearing.
Before sintering begins, every ceramic ball enters the debinding furnace. Here, carefully controlled heat removes the temporary binders, preparing each ball for the next high-temperature stage.
The debinding process happens gradually across multiple heating zones. Temperature and atmosphere manufacturally eliminate binders. This preserves the perfect shape of every ceramic ball.
Advanced automation keeps the debinding process consistent from start to finish. Intelligent sensors monitor every stage, ensuring each ceramic ball is perfectly prepared for. Inside this advanced furnace, silicon nitride ceramic balls are heated to nearly 1800 degrees Celsius, without completely melting.
Temperature control is critical during sintering. Every degree is carefully monitored to eliminate defects, improve density, and produce ceramic capable of handling intense operating conditions.
This controlled sintering cycle transforms fragile green ceramic balls into high-performance engineering components. The result is exceptional.
Inside this sealed chamber, ceramic balls are exposed to intense heat and extreme argon gas pressure. This advanced process eliminates microscopic pores. Automation ensures every ceramic ball receives identical heat and pressure conditions. The HIP process creates an exceptionally dense internal structure, delivering outstanding mechanical performance. Hot isostatic pressing transforms the ceramic from the inside out. Under intense heat and uniform gas pressure, hidden imperfections disappear, producing precision ceramic.
At this stage, the hardened ceramic balls enter rough diamond grinding. Powerful diamond wheels remove tiny surface imperfections while maintaining exceptional dimensional accuracy.
Robotic grinding systems work with micron-level precision, shaping every ceramic ball to exact specifications. Automated controls continuously monitor the process.
Precision grinding transforms hardened ceramic balls into highly accurate components. Advanced diamond tools, automated robotics, and real-time quality inspection work together.
This is where precision reaches the micron level. Diamond slurry and synchronized lapping plates remove microscopic imperfections, creating
Advanced automation controls every fraction of pressure and speed. Each ceramic ball is polished uniformly. This ensures consistent size and superior surface quality.
Every rotation is carefully monitored by intelligent inspection systems. Real-time measurements guide the lapping process, producing ceramic balls with world-class precision, unmatched smoothness. This is where precision becomes perfection. Using diamond polishing slurry and automated control systems, each ceramic ball is polished until its mirror polishing is formed in carefully controlled stages. Every cycle removes microscopic imperfections, producing an exceptionally smooth ceramic surface that, powered by intelligent automation, the mirror polishing process continuously monitors every ceramic ball. The result is a brilliant, ultra-smooth finish engineered. Every ceramic ball enters an ultrasonic cleaning bath, where millions of microscopic bubbles gently remove invisible contaminants. This advanced process cleans surface. The cleaning process even the smallest traces of compounds, ensuring every ceramic ball achieves laboratory-grade cleanliness before final testing. Using powerful ultrasonic energy, microscopic particles are lifted away without damaging the flawless ceramic surface. The result is a perfect clean, contamination-free component. Every ceramic ball passes through an advanced laser inspection tunnel. High-speed optical sensors verify its diameter with micron-level precision, ensuring flawless Multiple laser sensors inspect each ceramic ball from every direction, confirming perfect geometry and unmatched manufacturing accuracy. This intelligent laser measurement system inspects thousands of ceramic balls every minute. Any part outside micron tolerance is removed, guaranteeing exceptional product quality. Every ceramic ball is examined by advanced AI vision systems of detecting microscopic cracks invisible to the human eye. Only components continue to the next manufacturing stage. High-speed optical inspection captures every surface detail in milliseconds. Intelligent algorithms identify scratches, pits, and imperfections with unmatched consistency and precision. Using multiple inspection technologies together, the system verifies every ceramic ball meets strict quality standards. Even the smallest surface defect is detected before final approval.
Every ceramic ball undergoes an automated hardness test to verify its resistance against wear and surface deformation. Advanced sensors measure.
Extreme compression testing proves how these ceramic balls perform under enormous loads. Only components that survive intense pressure without failure move on to the next production stage.
Fracture toughness testing evaluates how well each ceramic ball resists cracking under extreme stress. High-speed imaging and AI analysis, exceptional strength and long-term reliability.
Every ceramic ball is placed with micron-level precision by advanced robotic systems. This flawless assembly creates hybrid bearings and remarkable durability.
Artificial intelligence guides every movement, ensuring each ceramic ball is perfectly aligned. The result, pristine efficiency in demanding industrial applications.
This advanced assembly process combines robotics, precision-engineered bearings built for maximum performance, extended service life, and superior reliability.
These ceramic ball bearings are pushed to incredible speeds, where every rotation proves their exceptional strength, precision, and thermal stability under the most demanding conditions. Engineers monitor temperature and vibration in real time, ensuring every bearing delivers smooth, reliable performance even during extreme operating conditions. Before reaching the market, every premium ceramic bearing must survive rigorous stress tests, proving its durability, efficiency, and long-term reliability in high-performance applications. Every bearing is automatically vacuum sealed to protect it from moisture, dust, and contamination. Robotic barcode tracking guarantees complete traceability from the factory to the customer.
Advanced automation carefully organizes every bearing into protective packaging. Smart robots assemble, label, seal each box with incredible speed, preparing every shipment for. The final stage transforms precision-engineered bearings into ready-to-ship products. Automated palletizing, barcode verification, and robotic logistics create a seamless packaging.
Every ceramic ball bearing begins its final journey through a global logistics network. By sea, rail, road, and air, these precision-engineered components reach industries that speed and precision define the modern supply chain. Ceramic ball bearings travel thousands of miles through fully automated logistics systems before arriving at cutting-edge factories. Speed and precision define the modern supply chain. Ceramic ball bearings travel thousands of miles through fully automated logistics systems before arriving at cutting-edge factories.